Sometimes you'll be asked to do something like this, where you're asked to find a point or a couple coordinates when given the slope of a tangent line. So we're given this curve right here, and in fact, instead of finding the dy dx, they actually give it to us. But what they want us to do is they want us to find all coordinate points on the curve where x equals 1. So when x equals 1, what y value or y values do we get? But not only do we want to find those, it says and we want to find the tangent line to the curve that has a slope of 1/5. And if no points exist, right, they do not exist. What I want to do first is I want to take my equation, this curve right here, and I want to plug in my x equals 1, and I want to see what happens. I want to see what y coordinates we have. So that would be a -1, so that's a negative y minus a y squared plus a 5, and the x is 1, so that would be -1. This is a quadratic, so I like to keep my y squared positive, so I'm going to move that over, I'm going to move that over, and then if I subtract the 5, we get that. All right, well, you know how to factor these, I hope. We need ourselves a y plus 3 and a y minus 2. When you set them equal to 0, we're going to get two y values. We're going to get y equals -3 and y equals 2, which means when x is 1, you can have either -3, or when x is 1, you also have a point 2. There's two coordinates on there. All right, well, let's see if one of them or both of them or none of them have a slope of 1/5. So here's our dy dx, and it was given to us that it equals this. We know the slope, the dy dx is 1/5. That's the slope of the tangent line, and we know that our x value is at 1, right? X equals 1, so we can plug in a 1 wherever we see an x because we know it's there. We just don't know what the y value is. All right, let's simplify this. So that's going to be -3 plus y, and that's a -1 plus 2y. Well, I'm going to cross multiply, and don't forget to distribute the 5, so that's going to be -15 plus 5y. 1 times anything is itself. This was a 2, right? 2y. All right, let me see. So if I move that over, you get 7y equals 4. We got ourselves y equals 2. So it looks like the point when x is 1 and y is 2 is the one with a 1/5. There's your only answer, 1, 2. Here we have a similar question. This is, they're giving us a dy dx, so we know the derivative. Our goal is to find all the coordinate points on the curve when x is -1. So we can plug it into here and find the y values. Then we need to take those points and see which ones of those have a 0 slope, which ones are horizontal, okay? I like to find my points first. All right, so here's the equation right here, and let me just copy it down so we all see it. X cubed equals -y plus 5. We know that x is -1, so we're going to plug in a -1 wherever we see an x and figure out what type of y values are generated. Well, that's negative, that's y, negative, that's -1, -y. And it looks like we are going to get y equals 3. Which means there's only one coordinate, -1, 3, which, all right, that's fine, but we still don't know if it is horizontal. Okay, we know this is a coordinate when x is -1, but let's see if it has a slope of 0. dy dx was given to us, and 1 minus x. So we want to see, well, let's find what is the slope of the tangent line. What is dy dx evaluated at -1, 3? It's the only point we have. Let's just see what happens. We have 3 minus 3, that's a -1 squared. And then we have 1 minus a -1. This is 3 minus, that's +1, so that's 3 minus 3, and this is 1 plus, yes, okay, so it does come out to be 0. Great. And since that's 0, we have 1 point, -1, 3. You may say that 3 of these examples are a little too much, but I want to make sure I go over one of these examples where we have vertical tangent lines. Let's move on. Here's the equation they give us, and then they give us the derivative. All right, we'll need the derivative. I'll just copy it down right now over here. And that was 1 plus y over this. Minus x. Let's get back to the yellow side. So the first thing I want to do is they're giving us y equals 1. All right, we don't know x, but we know y. So let's plug in a y equals 1 and figure out what type of xy points we have on the graph, on this curve. We know y is 1, so we have 1 cubed plus x times 1. This is -x minus 5. That's going to give us 2x over here. Subtract the 1, you get negative 6. X is a negative 3, which means we have 1 point, 1 xy point. When y is 1, x is negative 3. So we have the point negative 3 comma 1. What our question is asking now, since we only have 1 point, does this point, does it have a vertical tangent line? Well, if it's vertical tangent line, that means that this dy dx is going to be undefined. What makes it undefined? When that denominator becomes 0. Let's go ahead and evaluate. Let's see what is our dy dx when our xy coordinate is negative 3 comma 1. Plug in your y value, and negative 3, plug in your x value. That's going to be 2, negative 3, negative is positive 3. Aha, it is undefined. So we have 1 point when y is 1 and the slope is vertical. It's undefined. Now for a similar type of problem with a little twist. Not only is this one asking us to evaluate it at an xy point, 1, 2, but please be mindful of what they're asking us. We're not just finding the derivative, we're finding the second derivative. So be mindful of what they're asking. All right, let's continue, and we have to first find the first derivative. This term is an x term. It will become 6x squared. This is a y term. It will become negative 5 dy dx. The next term is a y term. That becomes 4y dy dx. And 0 is another constant. All constants become 0. Okay. Like we did before, we're going to identify which terms have a dy dx and which terms do not. What I'm going to do is I'm going to leave these over here. And then we're going to move the non-dy dx term over here. You could also move the dy dx's over to the right, but since they were all on the left, it just made sense to keep them there. We're going to do the same thing we did before. We're going to take out the common factor. Once they're all together, you can take the common factor out. And that is how you get dy dx by itself. What I'm doing here is nothing too new. I'm just same pattern, right? Oh wait, let me fix that before I continue. That's a y, and then I have negative 5 plus 4y. Okay. That cancels with that, and here's our derivative. Dy dx equals negative 6x squared over this. Okay, let's move on now to the second derivative. Well, yeah, let me just do it that way. So here's our first derivative. Well, we need to know what that point is, right? 1, 2. So I'm going to write that down over here in white. We have evaluated at 1, 2. So now we're on to our second derivative. The second derivative of y with respect to x. Well, we have ourselves a quotient rule. So I'm going to do this. I'm going to do negative 6. Oh, I'm sorry, that doesn't. You're going to take the derivative of the first, which is negative 12x. I'm going to leave the denominator. Plus, I'm going to leave the negative 6x squared and take the derivative of the denominator, which is 4 dy dx. All over the denominator squared. We did not take the derivative, we're just squaring it, so you don't need a dy dx. All right, let's clean the second derivative up. Negative 12, oh, here, let me distribute that. Okay, so distribute, we're going to have a positive 60x, and then we're going to have a negative 48y. When you multiply this over here, you're going to get negative, well, here I get, that'll be a negative 24x squared dy dx all over this. Now, what's the problem here? So now, think of this. So now we are asked to take the second derivative, and this is what we need to do. We need to evaluate this at 1, 2. All right, fine. I plug in 1s and 2s into the x's and y's, but do you see this problem here? What the heck do we do with that? Well, here's what we can do with it. There's one of two. This right here is dy dx. Let's just do it this way because this works for everything. You already know what dy dx is. Let's plug it in, all right? So you can substitute in what dy dx is, and that will leave you with all x's and y's. That's the trick. So it would look like this. We're going to multiply it by negative 6x squared over this plus 4y. Okay, so what you do is you just find what your dy dx is and you substitute back in, and what that does is it leaves you with all x's and y's. Now it is a complex fraction, but since we're evaluating it, it doesn't really make that much of a difference. We're going to get the same answer either way. All right, well, I'm going to go ahead and plug in my values now. So I have 60 times 1 minus 48 times 2 plus 24, 1 squared. And then we have to multiply that by a negative 6 times 1 squared over negative 5 plus 4 times 2. That's all over negative 5 plus 4 times our y value, which is 2, squared. We're almost there. That's a 60. 48, that's 92. And then that's a plus 24 times, and what do we have there? We have a negative 6. And that's 8. 8 minus 5 is 3. I'm going to call that a negative 2. Negative 6 over 3 is negative 2. What is the denominator? Well, this is 8. 8 minus 5 is 3. So we have 3 squared. All right, let's see what we got here. This is negative 40. Let me do it that way. Negative 48. So, oh heck, let me just get the calculator right here. Give me a second. All right, the calculator now says that we have a negative 80 over 9. And if you remember, 81 is divisible by 9, which means 80 is not divisible by 9. There is your second derivative evaluated at 1, 2. All right, let's finish this video up with another second derivative evaluated at the point 4, 1. Well, we must start with the first derivative before we get to the second derivative. This is a product rule, okay? This is a negative x times a y. So the derivative of the first is negative 1, leave the y, plus, now I leave the negative x and I take the derivative of y, which is 1 dy dx. Again, this confuses some people. I know I don't have a y in it. It's because the y just became 1. This dy dx goes with this negative x. Let's continue. The next term, this one is plus 3y. That becomes plus 3 dy dx. And over here, all constants become 0. Let's find our dy dx. Negative x dy dx plus 3 dy dx equals a positive y. Right, this one went over to the right side. Now I'm going to take out my dy dx. We have a negative x plus 3 or a 3 minus x, depending on how you wrote it. And we divide both sides. I'm going to skip that step. I think you know what I'm doing. I'm dividing both sides by negative x plus 3. There's our first derivative. But we must continue. We must see what it is, what the second derivative is. So this is pretty simplified. I'm going to just continue here. Let's keep that point up there. 4, 1 is our point. Let me just write that down. 4, 1. Well, now we're going to jump into the second derivative. And this is going to look like this. Let me change the color. This is my f, and this is my g. I'm doing the quotient rule. The derivative of y is 1 dy dx. I'm going to put the 1 there just to remind us. And then I leave the second, negative x plus 3. Minus, now I leave the y value, and we take the derivative of g, which is negative 1. It's all over the denominator squared. As with our last example, we now have to substitute in what dy dx was. Here's my dy dx. So that was y over negative x plus 3. And then we have the rest of it, which is negative x plus 3. Negative is plus y. And then we have this. Well, we don't really have to do that much more to it, because all we want to do is we want to evaluate this at 4, 1. We want to take the second derivative evaluated at 4, 1. So regardless, it's going to give us the same answer if we plug them in right. So the y is 1. The denominator is a negative 4 plus 3. And then this is a negative 4 plus 3. The y value is 1. The x value is 4, so it's negative 4 plus 3 squared. Our second derivative is, well, that's just a negative 1. And that is a negative 1. And that is a 1. And that is a negative 1 squared. And that's a lot of 1s. So that's 1 plus 1. That's 2 over 1. We have a second derivative of 2 at the point 4, 1.